So if we have, it says in each of the following, y varies directly with x. Just like the proportion. So all it means is that we have y over x equals k, which is a constant variation. It's also your rate of change, your slope, all that stuff. Which is on your paper. If we solve for y, get y on one side by itself, what's the opposite of division?
Multiplication.
Okay, so if I multiply by x on both sides here and cancel that off, I also can have this. They're the same equation. It depends on what you're given, which one is the easiest. You're still doing it, it varies directly. So if we're looking at our problems, on the first one, you're given x, k, and you're looking for y. If you're looking for y, then you probably want to do this. Because what this is saying is that for every x, you're multiplying it by 1/3. Right? Or if you want to say for measurement, people, whatever it is, this is changing. That is 1/3 of whatever x is. So, y equals 1/3 times 9. What's 1/3 times 9? 3.
6.
3. So we have 3. So this is the same thing. You're given k, you're given y, and you're looking for x.
So y equals
Here, you're looking for k. Well, if I'm looking for k, then I probably want to use y over x. This doesn't matter. You can put it up here. Still a one-step equation. But if I say y over x, what's that reduce to?
2/3.
3/4. 3/4.
These notes.
Yes. No, you did this. Okay, so you have 3/4 equals k. The same thing applies for all of them. But that's for constant variation. It's asking for k. Another way to say constant variation is your rate of change. Because if we're thinking about our example with the money and the movie, your rate of change is $8. Okay, it's changing by $8 every time you add a person. Or if every time you put another gallon of gas in your car, it's changing by $2.91. So that's your rate of change. You're filling it into either this one or this one, whichever one. Here, you had to multiply because you were given k and you were given x, which is the same thing because if you've got this and you multiply both sides, you do y. You do one. Skip down to the graph for just a minute. It says, tell whether the graph has direct variation. If yes, give the constant variation in the equation. A lot of explanation, and all it means is that if it's direct variation, not this on your paper, it must go through 0, 0. It must go through 0, 0. Constant variation simply means, just look. So it's real easy to determine if we have a graph, whether it's a direct variation equation or not. Because if you don't go to the show to buy tickets, you don't spend any money. If you don't put gas in your car, then you don't spend any money. So all of these are starting at 0 before you start making changes. So on number 10, is this direct variation? Yes? Got to cross at the origin. And so if it starts at the origin, we want to count our slope. How's it changing?
Over.
Up 1
Up
over
1.
4.
Up 1 over 4. So my equation is simply y equals 1/4 x. Because we have still y equals of x plus b. You want to put plus 0? You can put plus 0. We don't have to. So if it goes to the origin,
What direct variation and main slope?
a constant of variation, right, than what it's changing by. Direct variation means you start at 0
Okay.
and you change by the same amount each time. So on number 11, is that a direct variation? No. However, we can still write an equation. Where does it cross the y-axis?
Yeah, 2.
Crosses at 2, so I have plus 2 at the end of my equation.
1.
What's your slope? The positive or negative?
It's negative.
Negative. So I have -1 as my slope, and that's the equation number 1.
So, I don't get the part of the equation.
Where does this cross the y-axis?
What do you mean?
Where does the line cross the y-axis?
What, 0?
No.
Oh. 2.
Which is, and I count slope, down 1 over 1, down 1 over 1. What's your slope? Y equals mx plus b is every equation in one. So for 12, is this a direct variation? Yes.
Yes.
Crosses at the origin. What is my slope or my rate of change here?
1 over 1.
Still -1 over 1. So I write my equation, I have y equals -1x. We don't have to put plus 0 at the end because when it's crossing the origin, you don't have to have that. So, if we have it in an equation, we can use the formula. If you have it on a graph, it's going to cross the origin. If we have it in a table here and it says, tell me what is direct variation. If yes, give the constant variation in the equation. Pretty much the same question. All we have to do is make sure that these are the same. Whenever x has equal the same number, we're done. If it varies directly, that's what that means. It's changing by that $8 every time, that $2.91 each time, whatever it is. What's 10 divided by 1? 10. What's 9 divided by 4? 2.25. Are those the same?
No.
Nope. What on direct variation?
Wait, aren't you just gonna...
We're doing direct variation. We're not doing slope. We're seeing if the change each time is the same.
Oh,
Can you multiply this number by the same number each time and get these? No, you can't.
So the constant variation is the direct variation.
Constant variation is the slope number, okay, that we get from our graph. We're determining, is this a direct variation equation? Which means that you should be able to multiply this number by the same thing each time. Okay? Think about this one. What's 15 over 75?
0.2.
0.2, or 1/5. What's 10 over 50?
0.2.
0.2. What's 5 over 25?
So,
That would be the same thing.
0.2.
0.2. Or if I say 5 over 25, I can reduce it to 1/5.
0.2.
So, which is 0.2. So your constant of variation here is 1/5. It is a direct variation because all of these are the same. So I can write my equation. So in 13, if any time it says y varies directly with x, whether it's one of them, whether it's in a proportion, like it is right here on 15, you have that set up that you've got y over x. This one's given to you separately, written out. This one's given to you in a point. X and y. You're still gonna put those points in, and then you're gonna simplify. Look at 14. If it says that y is proportional to x, y is 8, and x is 10. What is y when x is 5? Where's 5 going to go, top or bottom? Bottom. So, half of 10 is 5, what's half of 8?
4.
4. So you can cross multiply, or you can simplify it in that way.
Wait, so
So you have 4.
it's 40 over 20.
Yeah, but if you cross multiply, if you're looking for this, it's 40 equals 10y. You're looking for y. You can check it by multiplying both, but you're looking for 4. Okay, I want to point out number 16. This is not a direct variation. However, it's simplifying, and some of us forget continuously how to do these. So we're doing distributive property. You cannot add different letters together, but you can multiply. You have negative 5x times 2x. What are we going to get?
Negative 10.
Negative 10x squared. X times x is x squared. 7x, oh, sorry, skipping one. Negative 5 times 7 is what? Negative 35. We have to keep the x and the y. 7xy is not touching either parentheses. We leave it. So we have to multiply, negative 4x times everything in parentheses. What is negative 4x times y? Negative 4xy. And what is negative 4x times 3? With the x. So when we want to look at what we can combine here, we can only put together like terms. Close, and then do your negative, you gotta add them all together. This right here, the first and last will tell you what your answer is, because you gotta have negative 12 at the end. So when you put those together, you're gonna get negative 32xy.
Wait. Why isn't it negative 22 today?
Well,
It's negative
this
10x and
and this is negative 39 minus, and then plus the 7 is negative 32.
I'm talking about, like, why didn't they combine the x's, negative 10 and negative 12?
Oh, because this is not squared.
Where does it say this one's squared? That's on
X times x is x squared. X times x. Okay, so you have several different problems there. This one gives you the equation. This one you need to put together what matches. Okay, the correct variable with the correct rate. And then you can tell which one is which.